Hi, and welcome to our video on annuities. Now, annuities are going to be a kind of a special kind of compounded um, interest bearing account. All right. So, when we're dealing with annuities, okay, we make a deposit every so often. Let's say, and it can be monthly, um, weekly, it can be biannually. Okay. So you'll know like how often you're making the deposit. And the thing is that we earn interest on every single balance that we have. Okay. So when we are thinking about annuities, okay, um, so what we need to consider is that every time we make a deposit, it's only earning interest for a specific amount of time. Okay. So let's say that we are saving up for a vacation. Okay. And we are going to start in January. All right. And we are going to deposit, we're going to deposit $100. Okay. And this account earns 12% annual interest. Okay. Which means since we're making monthly deposits, we divide by the number of months and it's 1% monthly interest. Okay. And let me write these other months out here. Okay. Because we are going to take our vacation in July. All right. So every month, we're going to deposit $100 into this annuity. Okay. Well, this amount that we deposit in January, okay, is going to earn interest. It will earn interest for January, February, March, April, May, and June. No, I take that back because it won't earn interest until the next month. Okay. So it is going to earn interest for 5 months. Okay. So using our interest formula, okay, we are going to say that this money, this amount that we've deposited, at the end of 5 months is going to be $105.10. Okay? The money that we deposit in February is going to earn March, April, May, and June. So 4 months. Okay? So it's earning that 1% interest for 4 months. And we keep doing this. The money deposited in March will earn for April, May, and June, which is 3 months. Which is 10303. The money that we deposit in April will earn for May and June, 2 months. And this is going to, the money that we deposit in May will earn interest in June, which is just 1 month. And the money that we deposit in June isn't going to earn any interest. So that's just going to be $100. So that means that in July, when we withdraw this money, we are going to have a total of $615.20 saved up for our vacation. Well, this is a really, really long way to kind of go around this. So it might be easier if we just have an annuity formula. Okay. So when we look at the annuity formula, we're looking at future value. Or FV. Okay. We have the monthly payment that we're going to represent with the letter R. Okay. We'll let M be the number of yearly compounding. We're going to let N equal the number of payments. And as always, we're going to let little r be the interest rate. Okay. So once we have all of that, we can say that future value is equal to the monthly payment times 1 plus our rate by the number of compounding periods, or divided by the number of compounding periods, raised to however many payments minus 1, divided by the rate over M. So this gives us a nice formula that we can use to calculate the future value of our annuity. Okay. So let's look at this in practice. Let's say that we are going to deposit $600 monthly into an account that earns 9.5% annual interest for 8 years. Okay. So, what is this going to look like as far as like our variables here? Well, this is our R. This says that little r, is 0.095. Okay. And this also tells us, okay, that M is 12 because we're making these payments monthly. And this right here tells us that N is 96, okay, which happens to be 8 times 12. Okay, so monthly payments for 8 years. Well, what's that going to give us in the end? So, what is our future value going to be? Well, we're going to have 600 times 1 plus the 0.095 divided by 12 raised to the 96th power minus 1 over 0.095 over 12. Okay. Now, some of you may have calculators that you can put this whole thing in right away and everybody's happy. One thing that I'm going to caution you about is that when it comes to doing problems like this, parentheses are going to be your best friend. Okay. So I'm going to kind of walk this through a little bit. Because if you are unsure of parentheses and like where they should be placed, okay, that can create a huge problem. All right. So what we are going to do is we're going to start out. This is going to be 1 plus, and I'm going to put into my calculator 0.095 divided by 12. Okay. And this is going to give me 0.0079. And then I'm going to take it out this far and I'm going to round it. Okay. And if you notice that 0.007, that is also what is going to be in the denominator because that is 0.095 divided by 12. So 0.007917 will also go down here. Okay. So now we can add 1. Okay. So this is going to give us now 600 times, and this is going to be 1.007917. raised to the 96th power, and then minus 1. Okay. So if you notice how I'm only doing like one kind of piece at a time. Okay. So this next one, if you haven't guessed already, I'm going to take the 1.007917 and raise it to the 96th power. Okay. And this is going to give me 2 point, let's see, 131. We want to leave it out. Let's see, I had done 6 decimal places. So let's keep it out to 6 decimal places. Because the longer you leave it out, the more accurate your answer is going to be. If you try to, um, if you try to shorten your decimal too much, like make that like 2.1 rather than 2.131887, then you're going to end up with an answer that at the end is going to be several cents off. And um, depending on the grading scheme for your class, you may or may not be able to get partial credit for that. This is why many of you, your instructors, are going to tell you, please show your work. This is really, really important for you to show your work, because if you do make a careless error somewhere, um, by showing your work, it can really help us pinpoint where that problem is and, help fix it from there. Okay. All right. So now I'm going to do the next step, and I'm going to subtract 1 from the 2.131887. Okay. And now I'm going to take that and I'm going to divide it by the 0.007917. And again, I would recommend keeping it out 6 decimal places. Okay. And now finally multiply that by 600. And now this is where we will give our final answer in dollars and cents. So this means that at the end of this 8 years, we would have $85,781.50 in that annuity by making $600 monthly payments and earning 9.5% annual interest for 8 years. That's quite a chunk of money. And annuities can be a great way to save for large purchases. So, um, say you are wanting to save for a house. An annuity can be a great way to do that because you are compounding the interest. Um, and you're compounding at usually a pretty great rate when we're talking about annuities. They usually pay really good rates, much better than just a plain savings account. Um, because they are expecting the bank is expecting to have your money for a specific amount of time. Like when you set up the annuity, you set it up for 8 years or 10 years or 5 years or whatever. So they give you a really great rate on that. And when you consider that, you can see here at this interest rate, in 8 years, you've got over $85,000 saved up, which would be an amazing start to buying a new home. So annuities are a great thing to invest in early on in life. Um, even if you can't make $600 monthly payments, if we were to reduce that to $100, like let's just kind of look at that. If we were to, let's pretend that rather than doing $600 payments, let's instead say that this was actually 100. Okay. Well, even if you take $100, if those were $100 payments and you multiply that everything else is the same. Okay. We're still paying the same, or we're still earning um, the same interest. Okay. At $100 payments, that gives you $14,296.92. So you can play around with annuities, and $14,000, that's a great chunk of change for only saving, $100 a month. And you can shop around for annuities and get different interest rates. But yeah, great way to invest your money to save for large purchases, such as an education, 4 year or more education, or possibly the purchase of a new home. Um, so that is everything about annuities. Okay. So we do have the future value formula. All right. You have your monthly payment. And then we're multiplying it by this interest rate formula that we've used in previous applications for compounding interest. And that gives you the future value of the annuity. So if any of you have any questions, please be sure to reach out to your instructor. Remember that your instructor is here to help you in any way possible. Thank you for listening.